Dave Staublin here. We're continuing our discussion of geometric series. And let's look at this same series again, but there's one minor difference. You will see that we start at 1, multiply by 5, times 5, times 5, times 5, plus dot, dot, dot. We now have an infinite series because this dot, dot, dot indicates that we're going to keep multiplying by 5s forever. So with that in mind, let's start by writing the explicit equation. We know that the first term is 1 and the common ratio is 5 because we're multiplying by 5 each time to get the next term. And for a geometric sequence, the nth term is equal to the first term times the common ratio to the n minus 1 power. And now let's write this series using summation notation. So we use the sigma, which stands for sum, or add up all the terms, and our explicit equation is 1 times 5 to the n minus 1. And we are starting with the first term, and here's where it gets interesting. In a sense, we are not going to the 1, 2, 3, 4, 5th term, or the 6th term, or the 7th term. We're going on out forever. We are going to infinity. And so that's what this means. Now, the last thing that we have to do is evaluate this series. And there's a couple ways we can do this. One way is we could start with the first term, and so we get 1, and then we can take the value, we can add the next one, which gives us 6, and then we can add the next term, which is going to give us 31, and then we can add the next term, which is going to give us 156, and so on and so forth forever. Now, there's another way that we could think about adding this up, and we could do it in terms of a graph where this is the n value and this is our sum. And so when n equals 1, our sum is equal to 1. And when n equals 2, our sum equals 6. And when n equals 3, our sum equals 31. And in a sense, this thing is growing exponentially. And in fact, our explicit equation, a sub n equals 1 times 5 to the n minus 1, looks very similar to y equals a times b to the x, which is exponential. And so what we have here is exponential growth. Why? Because this b value, which is also our common ratio, is greater than 1, and so we have exponential growth. So because this is exponential growth, it keeps getting bigger and bigger and bigger forever, and we would say that this diverges. It blows up. It just keeps getting bigger and bigger and bigger forever. So the rule that we can get is if our r value is greater than 1, then the sum diverges. And diverges means that it just keeps getting bigger and bigger and bigger. The farther towards infinity that you get, the bigger it gets. It just blows up. It explodes. It diverges. So, is there an answer for n equals 1 to infinity of 1 times 5 to the n minus 1? There is not a single number. We say it diverges.